Let's begin lesson 2 in our series on rational expressions. The topic right now is equivalent fractions. And before we begin equivalent fractions, I need to remind you, to be able to do this very effectively, you need to be very, very comfortable multiplying numbers and dividing them mentally. So know your times table. Equivalent fractions are defined as any two fractions, even though they will look different, the numbers are going to be different on both fractions. In fact, the value of both fractions would be the same. They would cover the same amount of space on a shape or a pizza or something like that. For example, 1/2 and 2/4 mean the same thing, even though the values or the numbers look different. They both cover a half of an object. Here's the rule for creating equivalent fractions. Multiply the numerator, the top number, and the denominator by the same number. Or if you'd like, you can divide the numerator and the denominator by the same number. What you are not allowed to do is add or subtract you can't do add 1 here and add 1 there to make 3/4. That is not allowed. And likewise, you are not allowed to subtract from the numerator and the denominator. The only thing you're allowed to do is multiply them or divide them. And whatever you do to one, you have to do to the other to make the value preserved, to keep the value in check. Let's create 3 fractions like it's asking us to do that are equivalent to 2/3. Well, one thing I can do is I can times this by, say, 2. And I have to do the same to the bottom. What I multiply by does not matter. What matters is I do it to both of these numbers. And if I do that, I will get 4/6. These two fractions are the same. Now, if I chose not to multiply by 2, I could do something else here. I can multiply instead by 3. But I would have to do it to both of them. And if I did that, I'm going to get 6/9. So I'm going to get 6/9. And these two fractions have to be equal because this last one is equal to this. And this one here is equal to that. So they must be equal to each other as well. So we'll make them all equal. And we'll make one more. We'll erase these ones here. And we'll pick a different number to multiply by. Let's do 7. So if I did this, I'm going to get 14/21. And we've created 3 equivalent fractions. 1/2. Now, so that I don't erase every time and waste time, let's just do this. I'm going to write it on this side. I'm just going to write 2 and 2. And you know what I mean. I'm talking multiply by 2. If I do that, I'm going to get 2 on the top and I'm going to get a 4 on the bottom. So these two are equal. If I multiply by 3 and I do that to both of them, I'm going to get 3 on the top and 6 on the bottom. 3/6. Multiply by, let's do a crazy number. Let's do 100. I'd have to do that to the denominator as well. I'm going to get 100 times 1, which is 100, and 100 times 2 is 200, and the value is preserved. All of these fractions, this one, and that one, they are all the same value. They are equivalent. When the question asks you to reduce the following fractions, it's asking us to divide. Specifically divide. You're not allowed to multiply. You have to divide. That's what shrinks numbers down. That's what reduces them. But you need to divide by the same number. So let's say I choose to divide this by 2. What does that mean I have to do to the bottom? Yes, divide it also by 2. And I will get 8/12. If I don't want to divide by 2, I'd have to divide something. Now look, reduce. I did reduce this, but I can reduce it even more. Look, 8/12, I can break that down. I can divide this by 2 now and divide that by 2, and that would make 4/6. And then I can divide both of those again by 2 to get, let's go here, divide by 2, and then I would get 2/3, and that is the absolute lowest form I can go. But it doesn't ask me to put it in lowest form. It just asks me to reduce. And I reduced it 3 different times. And this fraction, and this fraction, and that one, they are all the same value. They are all equivalent. How about 35/42? What can I divide both of them by? I can't divide, I could divide 35 by 5. But I can't do that to 42. Doesn't work. So I have to pick a number that works for both. And you know what that number is? It's 7. Yes. So this makes 5, and the denominator makes 6, and these two fractions are equivalent. group the equivalent fractions together. Here's an activity for you to try. You can pause the video and go for it. Let's take a look at this. What I recommend you do is you start with the smallest fraction, the smallest numbers, the fractions with the smallest numbers. So that's going to be 3 over 4. And what we have here are a whole bunch of other fractions that could be related to 3 over 4. For example, if I put this beside it, are these equivalent? Well, look at the denominator. The only way I'm going to turn 4 into 24 is if I multiply by 6. But if I do that to the top, which is the rule, you have to multiply by the same number. I would get 6 times 3 is 18. That doesn't say 18 there. That says 16. So they can't be belonging to 3/4. I'm going to put it in the side group here. This is the elimination room. How about put these together? Well, there's no way I can turn 4 into 6 by multiplying it by, a nice number. So I'm going to put this on the side for now. How about this one? This might work because 4 times 3 is 12. So times this by 3 and you get 9. They are equivalent. How about 72? That's a big one. Let's put it on the side for now. How about 18 over 24? Let's move this away over here. How do we turn 4 into 24? It's going to be multiplied by 6. Times this by 6, you get 18. It works. So we're going to put all these side by side. They work. Now, how about 70? Now, this one here, this is a little bit tricky because 4 times what is 72? You might not know that offhand, but what about this? Look at the 24 and 72. If you times 24 by 3, you will get 72. And if you times 18 by 3, you will get 48. And since these two fractions here are the same as 3/4, that must mean 48 over 72 is also equivalent. Since it's equivalent to this one here, the rule says, they all have to be the same then. So then what about these two here? Where do these two go? Well, 4 over 6 and 16 over 24 are equivalent to each other. Why is that? Because 6 times 4 is 24. So if we times the top by 4 as well, we're going to get 16, and it works. So we've got these two together. They are in their own land, and we have this group here, and they go together because they are all equivalent to one another. Converting mixed fractions into improper fractions is another thing you need to understand about fractions. The rule is you times these two, and then you add the last number there. You're going to add this one. So 4 times 2 is 8, plus 3 is going to be 11. So we have 4 times 2 plus 3. You get 11, and you retain the denominator, 11 over 4. And these two are equivalent to one another. 4 and 1/2, let's apply the same principle. We're going to go 2 times 4 plus 1. That's going to get us 9 over 2. Let's move on. Convert the following improper fractions into mixed fractions. Now, I've done an in-depth lesson on this. You'd have to go back to my other grade 7 lessons to review this. I'm going to get right to the point of this. 7 divided by 3, 7 over 3. All you do is you go like this. Hold up your hand, hold up your thumb, and you're going to skip count by 3 until you get to 7, but not over 7. So count with me. 3, 6. I think that's as close as we can get. How many fingers do you have? You have 2. 2 holes. Now, once you get to 6, you have one more number left over to get to 7. So we're going to have one number left over out of 3. Double check it. 3 times 2 plus 1 is definitely 7 over 3. And these two are equivalent. And the last one, hold up your thumb. Now we're going to count by 4s until we get close to 15, but not over it. So count with me. 4. You should have your thumb up. 8. You should have 2 fingers. 12. That's as close as we can get. The next one will be 16. Too much. 4, 8, 12. That's 3 holes. Now from 12 to 15 is going to be 13, 14, 15. That's 3 more numbers. And keep the 4 in the bottom. Look, 4 times 3 plus 3 is 15 over 4. So we know we did these two right. Now we're going to find equivalent fractions to each of these ones here. We've done these already. Look, this is going to be 11 over 4. But it wants us to find equivalent fractions to 11 over 4. So what you do is you go like this. You can multiply this by 2. You can multiply this by 2. Now you've got 22 over 8. That's equivalent. We can instead multiply by 3. Both of them, and you get 33 over 12. And then if you want to multiply by 4, and you get 44 over 16. I'm out of room. Now for 4.5, always convert these mixed fractions to improper ones. We're going to get 9 over 2. And now let's dive right into it. Equivalent fractions. So let's times this, I don't know, let's times by 5, change it up a bit. So times this by 5 and we'd get 45 over 10. We can also times both by 2, both by 3, and we can complete this task by doing that. Now the last question on this page asks us to convert the following improper fractions into mixed fractions, and we've done that already, so let's skip it. Which fraction is larger? 2/3 or 3/4? Well, Mr. Melman, it must be the 3/4 because 3 is bigger than 2. Well, not so fast here. You can't compare fractions unless the denominators are both the same, and these ones are definitely not the same. But with equivalent fraction C, we can create equivalent fractions that have the same denominator. Look, if I times this by 4, and times that by 4, and times this by 3, I will get here 8 over 12, and I will get here 9 over 12. And now since we have both out of 12, we know which one is bigger, the one with the bigger numerator, and this is going to be the one. This is it. So we can put our greater than sign, and the mouth eats the bigger number. Now these two, again, do not have equivalent denominators, so we have to make them equivalent. Look, I can times this by 7, times that by 7, and then times this by 5. Look, they'll be both 35. Times this by 5, and now I've got 14 over 35. And this one becomes 15 over 35. Yes, we have equivalent denominators. Now look at the tops. 14 or 15. Yes, that one's bigger. How about 2 over 4 and 1/2? Look, I can make them both 4. I times this by 2. I times that by 2. Now I've got 2 over 4. And this is 2 over 4. They're equivalent. I put an equal sign. And this one here, we have one's a 4, one's a 6. I can make them both into what? Look, 4, 8, 12. Yes, I can make that into 12 as well. So I times this by 3. I times that by 3. And this one's going to multiply by 2. And this is going to multiply by 2. Look, I have 18 over 12. And here I've got 16 over 12. And 18 is bigger than 16. So it wins.